In this video, we're going to take a look at how we can interpret the values of the slope and the y-intercept for a line of best fit. Now, I'm definitely going to be asking questions like this in exams, so it's a very important thing to make sure that you understand how to do. It's actually very, very simplistic, and so we'll start here by taking a look at how we interpret the slope. Now, on this question, what we've seen so far is that the value of my slope was kind of sitting right here in front of where my x used to be. This was my value of b. And my y-intercept value was sitting over here as that value of a that was all by itself. Remember that the number that occurs in front of where x belongs is always my slope. And so I can see that even when I take a look at this kind of more general equation that I have up here. This value of negative 0.0046 is my slope, and the value here for my y-intercept that I'm going to use is my 34.7359. So let's look at that slope value and try to interpret it. So in order to be able to interpret slope, I'm going to go ahead and quickly write it down in the following way. Remember that that was the value b that the calculator told me. It was negative 0.0046. To make this interpretation easier, I'm actually always going to take this value and turn it into a fraction by dividing it by 1. And then I'm going to actually go ahead and think about the units that go with these numbers. You might recall from back in an algebra class that when we thought about the idea of slope, we often thought about it as a rise over a run, or a change in y over a change in x. And this idea is very helpful when trying to understand how I place units on here. The key is that I want my y units to be up top and my x units to be on bottom. So here in this question, my x units were weight of a car, so this would be pounds, and my y units were miles per gallon. So when I look at my slope here, what I see is that I have something that looks like negative 0.0046 miles per gallon over 1 pound, or per pound. And so this is exactly how I make my interpretation. I would write something like this. For every additional pound in the weight of a car. Notice I'm dealing with this bottom part first. I want to talk about what happens to x first. And this says for every 1 pound in the weight of a car, my highway miles per gallon, I'll say here the predicted highway miles per gallon, and the negative here is going to indicate that it will decrease or goes down. So this goes down by 0.0046 miles per gallon. Notice that I started talking about x first, and then I talked about the y. So for every additional 1 pound in the weight of a car, the predicted highway miles per gallon goes down by 0.0046. Notice here that the negative sign that I had up here kind of got translated into this phrase of goes down by. And I didn't include the negative on the number over here. That's very important. You can't say that this goes down and then also put the negative over here. That would be very incorrect. Because if you say that you go down by a negative amount, that's like subtracting a negative, and that technically means that you're going up. So I want to make sure I don't have any negative on there. And this phrase goes down or decreases is what takes the place of that negative. Okay, so this is how I can interpret every single possible slope. If I can take the number, turn it into a fraction, put the units on it, I can kind of write out a sentence that looks just like this. To interpret the y-intercept, I have to keep in mind that the y-intercept is going to be, with a particular line, always a point that existed on my y-axis. So I'm going to do just a quick refresher on some algebra stuff here, just to make sure I can understand how I'm going to work with the stats over here on the left. Remember that this point down here, if that's my y-intercept, it has a set of coordinates. Now its y coordinate is a giant mystery. I don't know what its y is, but its x coordinate I definitely know for sure. What would the x coordinate be associated with this particular point? Well, if you're thinking 0, then you're absolutely correct, because notice I didn't move to the left or the right at all to graph this point. So my y-intercept here is always going to start with a 0, and the y value that I put in is going to be this y-intercept value, this value of a that the calculator told me right from the beginning, this 34.3759. So this is a 34.7359. So this here is my y-intercept, and if I want to interpret this y-intercept, it's really easy. I just keep in mind that I have a value of x at the start, and I have a value of y over here. And I can almost just write a sentence every time that looks something like the following. This says, if a car weighs 0 pounds, we predict it will get 34.7359 miles per gallon. That's all it is. It's just saying if a car weighs X, then we are going to predict Y. So if X, we predict Y. That's the basic structure of the sentence. Now, of course, if you read this sentence, you're probably going ahead and scratching your head a little bit and going, what the heck do we mean by saying that a car weighing 0 pounds is going to get some sort of miles per gallon? This is totally ridiculous. In fact, I'm even going to write this down here. This is a, oops, got to be able to spell. This is a ridiculous statement, right? I mean, this just doesn't even make sense. How could a car weigh 0 pounds and then get like 34 miles per gallon? So, of course, I might have expected that I could have gotten a ridiculous statement here, because remember, if x is a 0, is that actually an acceptable x to use with this line? And what I can see is, no, 0 is not even close to falling inside of this interval, and so there's no way I would want to use 0 and trust the result that comes from it. That doesn't stop me from interpreting what I have, but it does lead me to believe that I'm definitely going to end up with a ridiculous statement. I can see here that 0 pounds is not in the restricted domain. And so of course I'm going to get some sort of strange answer or value back. I might even notice that I can also get really weird values if I was to plug in values of x that were like extremely large. Like I bet if you went back here and you plugged in something like 50,000 pounds for x, you would get a miles per gallon for a car that seems also pretty ridiculous. Well, this hopefully shows you how you can go ahead and try to interpret the slope and the y-intercept for lines of best fit. Example number 4 is an example that's actually going to be left for you to try to practice with. It's going to model all of the exact same sorts of steps that we just did in the previous videos. And of course, I'll ask you to try to work through this on your own and then consult the solutions that are posted up in Blackboard.